Hello and welcome to week 11 here in Statistics for Psychology. And here comes a very important one. We're going to be getting into t-tests, same as we got into t-tests, the single sample t-test and its relation to z-tests. We're sort of leaving that behind, moving into the world of comparing means. Now, an important distinction between what we've been talking about before and what we're talking about now is when we were looking at a score in the z-score examples, or we're looking at a mean within the z-score, t-score sort of area, we were looking to see if that score was significantly different from what we would normally expect. What we are looking at now when we're comparing means, we're looking to see if the scores are significantly different from each other. It doesn't really matter if those scores themselves are significantly different from some sort of standard. We're just going to look to see if those means are different. And in this first instance, what we're looking at is the related pairs samples t-test, the actual name of this chapter. Very simply put, we have two samples. Wow, let's do that again. Two samples. Do I get balloons? Wow, I don't know why my computer did that. Because the statistics gods are happy. Here we are talking about t-tests and related samples here. So what we're looking at is the first one is the within subjects design, where we would take a test that measures some property and we give it to a group, and then over time, or we insert an intervention or whatever, we give that same test. And we measure to see if that group, that same group of people, had a difference in their scores between the first time and the second time. Assuming that any change within those scores would be because of whatever happened in the intervening period of time. The other way that we do this, same test, same statistics, we have two separate groups, two sets of different people. These are the related pairs. You have one group that is, in all intensive purposes, matched with another group of people. So depending on what you're measuring, you would have the group would be composed of the same age, the same gender, the same race, the same, whatever, or the same likelihood of being selected into that group with some randomness. That the two groups are pretty much the same people in all of those ways. Now, in the first one, they are all the same because it's the same group of people. The second one, taking one group and we're exposing them to the change or the environment, and the other group is getting nothing, and we're going to compare their groups. That is where we see entrance of the idea of a control group. Very, very popular way of doing this. Now, sometimes the control group is what we would expect to happen in the world. So I might take individuals from let's say I was going to introduce a new teaching method. I might take, let's say I'm doing two of these statistics classes. I'm going to try a new methodology for teaching about t-tests, and one class is going to get it and the other class is not going to get it, not going to get that new method. And then I see if there's any differences at the end of that chapter. Did people score better or worse or whatever because of that new way of teaching? One class is the test group, the other class is the control group. Very, very, very popular way of doing things. The other method is when, same idea, I take a group of people I test them on how much they know about a particular topic. Same. I introduce that new teaching method, and then I test them again to see if there's been a change in that. You can see sometimes where that's a good way of doing things, and you can see where sometimes the other way is doing is a good thing. Many of you are involved in recruiting subjects who you're going to divide into two groups, and you're going to compare the differences between them, and you're using some sort of criteria to divide those groups. So let's say I was going to I'm trying to think of one, but I'll actually use the one in the book. The example I use in the book is actually a related pairs sample t-test. Let me just get to it. The example in the book, it starts on page 231. I tell you that I got in trouble, and there was an incident at the show that started to spread around that I'm a crazy man, and that there were some negative views of me going around on campus. So the administration wants to make an intervention. They decide they're going to put together a video to explain to the campus that I'm okay and whatnot, and we want to see if that has any effect on students' perception of me. So if you look at page 232, we see we have one group. It's person A through J took a test that measured their perception of me, and they got scores of 15, 11, 10, 11, and so on. Then they watched that movie, and they took the test again. And you see the scores the second time they took it. Now, if you go over here, I go into the conducting the t-test. You open the data analysis toolpack. You go to the t-test related paired two samples for means. This will be the same test that you use whether you're doing within groups or whether you're doing matched groups. Doesn't matter. It's still the same test. Still the same statistical test, regardless of whether you're using a control group or not. You're going to get a dialog box, and that dialog box looks like this. This is your first range. This is the first set of scores. You put in the range of cells. Second scores. The hypothesized mean difference. This is your null hypothesis. So your null hypothesis says there will be no difference between these. The movie will not have an effect. So the hypothesized difference is 0, meaning there's going to be no difference. So you set that to be 0. You click out, the labels if you're going to include that. And then this is our level of significance. We're looking at 0.05. You can put 0.01 in there. All that's going to do is it's going to tell the software where to actually say it's significant or not. And we go to the next page, and we start to see the next image, and here's what we see as our results. This is the statistics for the before. This is the statistics for after. The mean of the before scores was 11.9. The mean of the after scores was 15.4. So we know that there was an improvement in people's perception of me after watching the video. We just want to know whether it's significant or not. Here's the t statistic. It's minus 2.97. And the one tail says it was significant to the 0.007 level. If we're looking at the two tail significance, we're looking at the 0.01, which is, again, less than 0.05. Now, if we were going to analyze this from a one tail, meaning did it improve people's perception? We're just looking at one direction. Yes, it did. It was significant to the 0.07 confidence level, way past the 0.05 level. So yes, we had a successful intervention. If we're going to look at it with the two-tail, meaning the video may have the opposite effect. And you can potentially see that. And if you actually look at the data itself, there's a couple people who had an opinion of me before, and it was lower after they watched the video. So it had the opposite effect. It wasn't enough. There wasn't enough of that occurrence to offset the major direction of the study. But if we wanted to keep in mind that this could make things worse or could make things better, we would do a two-tailed test. Nonetheless, it still met the criteria. So there was enough difference between the first test and the second test at the 0.05 level, whether you were doing a one-tailed test or a two-tailed test. So this is how we go about determining the effect of our interventions. Did they significantly change scores? So that's the whole thing about what this chapter is about. Now, in the discussion, I go into a little bit of playful thought about thinking about things that we would like to say. I'll just put it this way, kind of repeating from that. I often think when I'm in stressful situations, I'm driving away from that stressful situation, and I'm kind of rehearsing what I really would have liked to say. But I know I can't say it because it's not appropriate. So, what if you could test those things? What if you could actually create AI worlds and go in and okay, what I really want to do is test this. For good or for bad, maybe there was an opportunity to meet somebody and I didn't take that opportunity, or a famous person walks by and I didn't say the really clever thing that I would like to actually get them to notice that I exist in the world. But then there's also the negative ones. Someone yells at you and you just give them that very good response that you would have liked and kind of see the outcomes of that. So testing behaviors to see if they produce results will be the point of our discussion, kind of a playful discussion. And then the one assignment where we are looking at this one is going to be, I want you to conceive of it as the same thing, but this has a test group and a control group, the data for this one. So you have one group. Group A has some test scores. That's the test group. And then you have Group B, which is the control group. And you're going through that same exact process to determine whether or not the means are significantly different from each other. Now the T-score, the critical level score, whenever you look at T-tests, you're always looking at that critical levels. When you refer to a critical level, that's the T that you're shooting for in your data to either meet the 0.05 level of confidence or the 0.01 confidence. Now let's go way back. It's a good time to review that. The 0.05 level of confidence, maybe I haven't really used that term enough, but at the 0.05 level of confidence means that my results are such that, statistically speaking, there's only a 5% likelihood that it occurred by chance. That's one level of confidence. A higher level of confidence is that the t-test shows me that the difference in these scores is significant to the point that there's only a 1% chance that 1% likelihood that this came by chance. You're always looking for something, the least likelihood by chance is what you're looking for, but those lines in the sand are the places where we usually set our expectations. Remember, we're setting our level of confidence, we're setting our decision making prior to collecting data. So if I think I'm going to give myself a chance to see results, I'm going to lower my expectations. I'm going to say, as long as there's only a 5 or less % chance, that the likelihood that this came by chance, I'm good. Or maybe I'm going to push it to that next level and say, I'm not going to say this is significant unless it's less than 1% likelihood that this came by chance. So when we are shooting, we get the t-test that we've got. We can't change that. That's produced by the data. But then when we analyze whether we're going to call it significant or not, we get to see, well, how significant? Is it significant for me to have a 5% confidence level, 1% confidence level, or in the case of this example, it was the one-tail test was 0.007. That's it's 0.7%. Only 0.7% likelihood that that occurred by chance. That's a very good statistic. I can feel very confident in saying that those differences were true statistical differences. They didn't occur just because of a sampling error or anything like that, all the ways in which that could be an error. So I hope that clarifies a little bit about what those criteria are, 0.05, 0.01. Those are just markers in the sand that have evolved over the time in which we've been using statistics to make decisions about significance. Just they've sort of evolved out of the accepted ways within science for us to recognize significant differences. So that's it for this week. Enjoy that discussion, just kind of a fun thing to talk about, the forbidden experiments that you might like to conduct, and then having fun with the first of your t-tests. Next week, we're going to go into a different kind of t-test, and we'll talk about that then. Have a great week.